Hey everyone, welcome back to the channel. Gosh, it's been long since I said that. If you're not familiar with me, my name is Kunal and I am a DevOps and cloud advocate. That means I really love helping people out in terms of getting started in DevOps, cloud native, and even open source as well. I am also a community manager slash ambassador for the Kube Simplify community, which was started by Sayam Pathak. And again, here we aim at helping people get started with cloud native, open source, and all that fancy stuff. Now, this introduction was important because a lot has happened since the last I posted on this particular channel. I've been creating content on Twitter and on other platforms as well, and for Kube Simplify. But it's been quite a while since I interacted with you all on my particular channel, and yeah, here we are today, and I'm starting a brand new series which is called as K8s in a nutshell. Now, currently, I am studying for the CKA certification, which is the Certified Kubernetes Administrator exam. I'll link it down below in the description. But it's essentially teaching me a lot about Kubernetes from the very basics as well to some of the advanced concepts, right? And though I've been sharing about this particular journey with everyone on Twitter each day. If you follow me on Twitter, if you do not follow me on Twitter, you can just head over to my page here, right here, and you can see all the tweets I'm doing with the notes I'm preparing. But I felt that if I really wanted to empower and share my learnings with everyone, right, the learn in public, because I really love the idea of learning in public, I thought let's create videos of the concepts that I'm learning and take you all along my journey as well. So this is the main idea of this series, and it's not a course. It's not like Kubernetes from scratch or you learn everything about Kubernetes. Just me sitting down, sharing my learnings with you all as I study for the CK certification, because I really love learning in public and learning with you all. So today, this is the first video in that series, and we'll be studying about basics of Kubernetes. So what is Kubernetes? A very short introduction to Kubernetes, right? And the main crux of today's video is I'll be explaining the K8s cluster architecture. So what involves the Kubernetes cluster, right? What to say when someone asks you from front, okay, what is a Kubernetes cluster? What consists of a Kubernetes cluster? That is what we'll seeing. We'll be seeing a very huge diagram that I've prepared. And after that, I'll also show you running some commands in a live Kubernetes cluster so you can get the gist of what is happening here. Now, this is the first video of this series, and in my opinion, this is the only basic video you'll find. From the next videos, I'll be filtering out the important concepts from the CK curriculum, which I'm learning right now, and make videos on that. If you want to learn more about Kubernetes from scratch, and after watching this particular video, you are not able to understand, I'll suggest you to check out the Kubernetes 101 workshop, which I've also talked about in the end of the video as well, and I'll link it in the description box. That is on the Kube Simplify channel and made by Sayam Pathak himself. So if you want to learn Kubernetes from scratch, you can definitely refer to this. And if you would like to be a part of my journey in preparing for the CK certification and also the concepts that I'm learning, you can definitely follow this particular series. And I'll definitely try my best to explain all the concepts in a really simple manner so you can definitely understand. I think I've talked enough and I'll be talking throughout the entire video. But yeah, just wanted to give you this particular message, and let's jump into the video itself. All right. So before even moving on to the cluster architecture, right, the main crux of this particular video, I believe it would be good to introduce yourself with Kubernetes. What exactly is Kubernetes, right? If you're familiar with this, you can skip this particular part of the video and directly move on to the cluster architecture. But just to give you a short overview of what exactly is Kubernetes, right? All right, I hope you are able to see this. So what is Kubernetes? So Kubernetes is, firstly, it's an open source tool, right? It's completely open source and there is a GitHub repo. And the one thing to note is that it's a CNCF graduated project. So CNCF is Cloud Native Computing Foundation. If you have heard of it, that's particularly great. But if not, it's a vendor neutral organization that has a lot of amazing open source projects across the entire cloud native ecosystem, and Kubernetes is one of them. So it's a graduated project. The next point is it's a container orchestration platform. Now, if I put it simply, container orchestration means that it helps us to run multiple containerized applications at once. Okay. So if anyone asks you what is container orchestration, this is what it means. Helps to run multiple containerized applications in a really easy manner. All right. Now, a lot of automation is happening inside the Kubernetes cluster, right? Why do we use actually Kubernetes? What is the need of that? Because a lot of automation is happening there. So you can easily deploy your applications. Now, applications, I mean containerized applications, right? So your application should be in a containerized format to work with Kubernetes. So you can easily deploy your applications. You can easily scale up and down your applications with respect to the kind of traffic you are getting. You can easily scale up according to that, or you can easily scale down to basically reduce your costs in terms of maintaining your infrastructure and a lot of similar concepts. The last but not the least is it helps us to manage containerized applications, right? It automates the entire process of managing the containerized applications. Now, it's important to note that when I'm talking about managing containerized applications, I'm not just talking about a single container, right? I'm talking about multiple containers being managed at the same time. So if you see, for example, a real world application like Twitter or Instagram, now Twitter is x.com, but if you see these big applications in the industry, they do not run just a single container, right? They have multiple thousands or even 10,000s of containers running at the same time. So that is one of the best use cases when you got to use a tool like Kubernetes to manage all of these particular containers at once at a single time. Now, an interesting point to note is that when this all got started, right? So Kubernetes was not an open source project, but as it became open source and it got a lot of community support, and that is how what we know as today. So it was all from the community that it got support, and then it became part of the CNCF later on. And now Kubernetes is one of the largest open source projects that we know in the entire world. That is amazing. Last but not the least, it's important to note that Kubernetes is much more than a simple container orchestration platform or a tool, right? Now, what do I mean by that? It does much more than just managing or running containerized applications. As we go along learning about different topics in Kubernetes, right, we will definitely notice that it does a lot more than just managing or running containerized applications. So this was just a brief introduction about Kubernetes, to get you up to speed. Just a very brief, just a short introduction. And if you want to know more, I'll definitely suggest you to head over to the official documentation, the official site of Kubernetes, which is kubernetes.io, very simple URL. But you can check out the docs and understand more about what is Kubernetes and why it came into being, the main history of Kubernetes, if you're interested to know that. But I hope you are now up to speed to what is Kubernetes if you weren't familiar with that. Okay, now time for the main crux of this particular video, right? What I want to explain to you, the K8s cluster architecture. Okay, so why it's called as K8? Why the 8 number? Because if you spell out Kubernetes, the letters between K and S are 8 letters. So that is why the K8s name came into being. But okay, forget about that. Let's understand when someone actually tells you, okay, this is a Kubernetes architecture, right? Or a Kubernetes cluster. What do they exactly mean? Let's understand that. So before I jump onto this massive diagram that you can see around here, a lot of networks and things are happening. Now, if you talk about Kubernetes cluster, right, there are two most common terms that people actually use when we are referring to the whole architecture, and which will help you to understand better. One is called as node, and the other is called as pod or pods. Now, about pods, we'll study a little bit later. You can see in the diagram here. We'll get to that part a little bit later. But before jumping onto the architecture itself, I want to explain what is a node basically. Okay. So just zoom a bit. I hope you are able to see this clearly. So what is a node? Okay, forget about Kubernetes, just focus on this particular word node. So nodes are the actual machines that host your containerized application. Now, this is an important word. I mean hosts, not run. Running is something that a pod does, which we'll look into a little bit later. The important thing to note is that it hosts your containerized applications plus everything which is needed to function for the entire Kubernetes cluster. So node is one of the, I would say, heart of a Kubernetes cluster. You'll definitely see and relate to that when you will understand the whole architecture. But just node is basically the machines that host your applications and everything which needs to function the entire cluster. Okay, just understand that. Now, Now, there can be different types of machines. There can be physical machines, or you can have physical nodes. You have physical servers running at your particular house or your organization, or you can have virtual servers or virtual machines. Now, usually when we talk about local Kubernetes cluster, or whenever someone talks about learning about Kubernetes or using Kubernetes, we generally are referring to these nodes as being virtual. Generally, we use the term nodes with virtual machines, but it might be the case that you are using Raspberry Pis or certain type of hardware to run these particular nodes. In that case, those would be physical machines or physical nodes. Okay, I hope you got the gist of what is a node, and we'll study more when we dive onto the architecture as well. Now comes the most interesting part of the video, the architecture itself. Okay, so after this video, if anyone asks you, hey, what is a Kubernetes cluster? You'll definitely be able to explain to them what are the components and what consists of a Kubernetes cluster. Okay. So as I mentioned, right, the main component, the heart of a Kubernetes cluster are nodes. So you have two types of nodes in Kubernetes. The one is the master node or the control plane node, which is this one, this blue one right here, and the other are worker nodes, right? You can have multiple worker nodes, but you only have a single control plane or master node when we are talking about a normal Kubernetes cluster. Okay, yeah, normal Kubernetes cluster, because you can have different type of Kubernetes. There is something called as HA Kubernetes cluster, which is also called as highly available. So in that case, you can have multiple master nodes as well. Okay, but right now we are focusing on the basics. So let us assume we have only one master node, okay, one control plane, and that would be the very common use case of that. Okay, so what are the components of a master node or the control plane node, right, as it is commonly referred to as? So one thing I would like to mention is all these components are also called as the control plane components. So these are a few terms that are commonly used in the ecosystem, or whenever you read a blog or an article or something. Don't get confused if people are using some other terms. These are the most common terms that are used. So master node, control plane, and these are called as the control plane components. Okay. Now, the number one is the API server. Okay, let us see that. Let's see each component one by one. What does it do? And after that, I'll also show you how does the whole workflow goes in terms of deploying or managing your containerized application. Okay, so Kube API Server, or aka the API Server. Again, Kube API Server is one of the common terms that is used with the API Server. That's another name, but the idea is the same. Okay, you can call it API Server, you can call it Kube API Server. All right. So essentially, Kube API Server or the API Server is the brain of your entire Kubernetes cluster. Now, what do I mean by the brain? All the administrative tasks in your Kubernetes cluster is done by the Kube API Server. All right. The main function it performs is, number one, it exposes the Kubernetes API. So there is a main Kubernetes API, and all the components which need some operation to be done are talking to the Kubernetes API. But it's important to note that they directly cannot communicate with the Kubernetes API. Again, that would be a very massive security vulnerability. Kube API Server exposes the Kubernetes API, right, for other components to communicate with it. Now, a connecting point to that is, because Kubernetes API is being exposed by the Kube API Server or the API Server, all the components, all other components which we'll see in the cluster architecture that you can see here, or these are a lot of components are board here. So all these components talk to the API server. API server is the only component in Kubernetes which is able to talk to every other component of the entire cluster. Right? That is a very important point to note. Each and every component in Kubernetes talks to the API server, be that telling it about its current state, or if it wants to process any requests, or if it wants any new request. Every new request, every external request comes first to the API server. API server first receives the particular request every time you give an external request to your Kubernetes cluster, right? All the requests are first received by the API server. So you can consider API server as a letterbox basically, and the post office is the Kubernetes cluster, the entire cluster, right? So you have a letter, right? You have a letter is sort of a request. So you have a letter, you give it to the firstly the post box, right? You drop the letter into the post box. So post box is basically the API server, which is the first one that receives your letter or your request, and then it transfers your request to the entire cluster, that is the post office. I hope this analogy makes things clear for you. Okay, so what are the main operations performed by the API server, right? Once the request is received, right? I'll explain what the request looks like when we'll head to the CLI tool, what is used with the Kubernetes cluster, but just understand that each request is passed through the API server first, okay? We'll talk more about what kind of request we do, right? So what are the main operations performed by the API server? So whenever a request is received, right, firstly it will authenticate the user who has sent the request, right? This is a very important step. We'll understand more about how it authenticates. There are two terms, right? One is authentication, right, and the other one is authorization or validation, right? So authentication means, is the right user sending the request, right? This is the first one. Is the user correct? Is the user who's sending the request is a genuine user, right? Or not a hacker or some kind of proxy server sort of things like that, right? This is authentication. Authorization or validation means that, does that particular user have the required permissions needed to perform the operation? Does it have sufficient permissions? So authentication means, is it the right user who's trying to access your cluster? And authorization or validation means, does the user have the necessary permissions to perform a certain action or a certain task in your entire cluster? Okay, so first it will authenticate the user, right? The next it will validate the request. Validating the request, it would see that, okay, what are you requesting, and according to that, do you even have the permission? Does the user even have the permission to perform that kind of action, to make that kind of request, right? That the API server will decide. Then it will retrieve the data from the entire cluster, retrieve the state from the entire cluster according to the request that we have made, right? And then once it retrieves the data, once it knows, okay, this is the request, this is something that has to be done, after that it will update etcd. Now etcd we'll talk about shortly right now, but just understand etcd is the database of a Kubernetes cluster, okay? So it will store the information or the request in etcd, and then only after the data has been stored inside the etcd, the database of our cluster, the request is forwarded to the scheduler. Again, something we'll discuss about a little bit later. And after that, last but not the least, it communicates with the kubelet and the request is moved forward from that. So there are three new terms that we use right now. We used etcd, we used scheduler, and we used kubelet. So all these three are separate components in Kubernetes, and we'll definitely come to them shortly. So these are some of the things an API server does. I hope you're able to understand. So just to recap, Kube API Server is the main brain of the Kubernetes cluster. It exposes the Kubernetes API so that all the components can communicate with that through the API server, not directly to the API itself. The most important point is, all of the components in the cluster communicate to the API server about their state or any new request that they want. Everything is communicated through the API server. Last but not the least, every external request is first received by the API server. And once it's received, these are the operations that it performs on that particular request. Okay, you'll understand more about these particular operations once you get hold of what is etcd, what is scheduler, or what is the kubelet. You'll understand more. All right, so this was the API server, the main brain of our cluster. The next one is the scheduler. We are talking about the main node right now, the control plane components, right? The control plane node. So if you see the scheduler now, let me just quickly change the color of the pen. I don't know, this one maybe. Yeah, sounds good. Okay, so kube scheduler, or simple a scheduler, right? Now, what is the function of a scheduler in the cluster? The main function, the important thing to note here is that it finds the best fit node to run your pod. And best fit node, we have the worker nodes we are referring to here. Okay, we'll understand more about what are worker nodes, but just note that it finds the best fit nodes to run your pod. And assume you didn't even hear about pod, assume that it's the containerized app that you have. That could be a Next.js app, a Node.js app, or maybe a Django application, or all that fancy stuff. So it finds the best fit node, finds the best fit machine, not even node, you can refer it to as machine, finds the best fit machine to run your containerized application, to run your particular app. Again, forget my handwriting, please. Forgive me for that. Now, what are the factors involved? How does it know, okay, this is the best fit node, right, to run your application? Some of the factors involved, these are not limited to only the ones that I mentioned here. There are a lot more factors, but these are sort of the main ones that the scheduler actually looks for. One is the resources. So the amount of resources needed to run that particular application, right? The number of requests that the pod or your application makes, it depends on that. And the hardware, software, or any other policy or rule constraints that you have defined in your application while you were defining your application to be able to run on the cluster. So these are the few things that it takes into account in order to find the best fit node or the machine to run or host your applications. Okay, now if there are any issues, it again reports any issues to the API server. As I mentioned, all the components talk to the API server, right? So Kube Scheduler is one of the components as well. In the master node itself, again, it talks to the API server for any more request, or if it finds any issue in terms of scheduling any pod on or your application on any of the nodes, it reports back to the API server. So it reports any issues to the API server. Some of the concepts we'll study in a little bit later videos, how it does the scheduling. These are the concepts that are involved. So one is node selector, node name, node affinity, taints and tolerations. If you're involved in the Kubernetes ecosystem and you have been studying about Kubernetes, so you would have definitely heard of these terms. If not, just note right now, these are the certain concepts that it uses that we'll actually use to schedule our application on a particular node, the worker nodes, right? Just note that, the worker nodes. So that was the Kube scheduler. So once the request is received by the API server, it heads over to the scheduler, as I mentioned in the operations right here. So once the request is received, it first gets updated onto the etcd. We'll look about etcd just now. And then the request gets forwarded to the scheduler. And after that, the application is scheduled on one of the worker nodes, right? According to the factors that we just discussed right now. Okay, so before moving on to the controller manager, I'll just introduce you to etcd because we have talked about it a lot, mentioned a lot of times. And it's definitely a very important component in the control plane components that we just talked about. Okay, so in etcd, there are two things to understand. For the time being, forget about you are using etcd in a Kubernetes cluster. So etcd in itself is a separate open source project, right? So it's a CNCF incubated project. It's completely open source, and we use it, we implement it in the Kubernetes cluster, right? So right now, forget about it being used in the cluster. Let's first understand what is etcd as a project on its own. So etcd is a data store. It's a distributed key value data store. So by key value, I mean sort of this kind of format. So it's like a dot Kunal. Again, don't see the handwriting here, but just understand the concept. This is the key, and we have the colon, and this is the value. So if you're familiar with YAML, you would definitely know this kind of syntax, right? So this is how it stores the data, all the data that we input into it. So it's a distributed key value data store. Okay, stores data in form of directories. Now this is the inside part, and how it structurizes the data, that it is given right here. So it's like a file system, right? So how you store data in your file system, you have directories, then you have subdirectories, then inside that you have more subdirectories maybe, and inside that you have your files in which the data is stored. That's how it's stored, and that's where the name comes from, distributed. It distributes your data in a very structured manner, like this kind of folder or directory system as your file system. So that's why it's called as distributed key value store. Okay. The format it supports either YAML format, you might be familiar with YAML, or JSON format, right? So it supports both the type of format in terms of writing your data into it. It's a CNCF incubating project. That means it's in the second stage. So there are essentially three stages when we talk about a CNCF projects. One is the sandbox stage, the incubating stage, and the graduated stage. Kubernetes is a graduated project, right? And incubating project is etcd right now. Now, etcd as a project, how you can download it, you can install the binaries from the etcd's main documentation, and that's how you will be able to run etcd, the key value store, as a separate service in your particular laptop or your host system. Okay. The default port at which etcd operates is 2379, and there is a CLI tool called as etcdctl, or etcd-ctl, whatever you want to call it, which helps you to interact with the etcd data store directly, right? So you can use this particular tool right here, and it will be installed when you will install the etcd service onto your particular system. Okay, so this is etcd, right, the project itself. Now let us see the main function of etcd in the Kubernetes cluster, right? What is the main implementation of etcd in our particular cluster? So etcd in Kubernetes, it stores all the cluster related information, as I mentioned, what requests are being received, what requests are being processed, what are the components right now, what are the applications running, and all that fancy stuff. All the data, all the cluster related data, the IP addresses, and all that kind of important stuff that we would need is stored in the etcd data store. Okay, now this is important. Why are we actually considering storing all the data, right? Firstly, it's a good practice, to be honest, to store all your data, when especially when we are talking about a production use case. But the main essence of storing the data in your etcd folder, sorry, the etcd database, is it can be used to back up your cluster data. For example, your Kubernetes cluster, due to some failure, one of the nodes, these particular nodes who have, hosted applications, it goes down. Okay, it completely vanishes and all the data is lost. It is not lost if all the data is stored in your etcd, right? It will not be lost, and you will be able to easily back up and restore that particular data to the original state. That is a very important concept, the backing up and restore of data using the etcd backup, and we'll study it separately in a separate video, right? This is a very important concept. Just note right now, it helps us to back up and restore the data. This is the reason for why we are, storing our data in etcd. Okay, again, another important point to note: the operation is considered as complete. Each operation is considered as complete after it has been updated on etcd. If I go back to the Kube API Server explanation, right, where is that? Yeah, right here. So the main operations that the API server performs. So first it will authenticate, then it will validate our request, then it will retrieve the data of what exactly do we want to do. Then it will first update the etcd with the data, right? Only after the data is being updated on the etcd, it will move ahead to all other operations. So before even moving on to other operations, the data has to be first stored in your etcd component, the key value data store, and only after that the particular operation, the request which is received, is forwarded, and it is considered to be as the complete operation. Okay, this is again a very important point to note. Data is updated on etcd, only after that a particular operation is considered to be as complete. Okay, important point to note. Now, how you can install etcd? One is the manual way of installing, which is called as the hard way of installing the Kubernetes, the hard way, if you are familiar with that. So you can install, as I mentioned, using the etcd binaries, and you can also install the etcd-ctl, the command line tool, which you can use to interact with the etcd itself, the data store itself. Another way is you can install kubedm using kubedm, which is again a way of installing a Kubernetes cluster, all the components, but it is simpler than installing it manually. And in here, etcd runs as a separate pod, a separate, we'll understand pod, but consider this: etcd runs as a container. Okay, just forget about pod, just see etcd run as a containerized application. Okay, if we install Kubernetes cluster, if we install all the components using kubedm, all right, and the port is same, it runs on 2379 only, and you can interact with etcd using etcd-ctl itself. Okay, this is the everything is same. The only difference is, if you'll install etcd locally on your system, it will be installed as etcd service. If you install using kubeadm on a Kubernetes cluster, it would be installed as a pod or a containerized application. If you'll install it manually, it will again be installed as a service only, right? This is an important point to note. All right, so this was etcd. I hope you were able to clearly see why etcd is so important, and this is kind of the uh, icon or the logo of the etcd project. And now I think you'll be able to figure out the etcd part of this particular stage, right? Updating the etcd. So the cluster related information is updated onto the etcd itself. Now, again, an important point to note is that API server also communicates to the etcd, and etcd can communicate back to the API server in terms of if any issues happen or an invalid data is being stored, so it can talk back to the API server, right? This is again a point to note here. Okay, so let us talk about the Kube controller manager or the controller manager component of our master node or the control plane node. So before moving on to the component itself, let us understand what is a controller. So a controller basically are functions or the control loops in the Kubernetes API that watches for a cluster state, right? The current state of your cluster and tries to match it with the desired state of the cluster, right? So when we are talking about making a request to the Kubernetes cluster, right, to make some kind of changes, we declare that these kind of changes are to be made. For example, what do I mean by declaring the changes? There is a really nice analogy for that. So for example, you are here, right? This is you and this is your house, okay? And this is the path to your particular house. All right. Now there are two ways. One way to command this particular user to reach this particular house is that you can command the direction. Okay, you can say like, okay, go to point A, then go to point B, then point C, and so on, and then you'll reach your particular destination. This is the imperative way of doing it. Now the declarative way of doing it, we'll just say, okay, this is your particular user and this is your particular destination. Create the best fit possible path to reach the destination. That's it. Nothing fancy in between. We'll not mention explicitly what path to follow. We'll just define the starting point and the desired state that we want this user to be in. So we want this user to reach this destination. No matter what path is chosen, just make this user reach this particular destination. That is the declarative way of doing things. So in Kubernetes, we often work with the declarative way of defining things, right? So we declare, okay, we want this containerized application to run on a Kubernetes cluster, right? We want this to be happening. Okay. Once we make that particular request, the controller's job is to compare the desired state, the desired request that we made, and the current state of the clusters. For example, you wish the Kubernetes cluster to run a Redis application, right? A Redis container. So you'll define in a particular file, okay, so we define what the application should look like in the YAML file. Everything in Kubernetes is related to YAML. We define everything in a YAML file, and then sort of we are commanding the cluster to do this particular thing. So we'll define all the information that we want for the Redis application, what the Redis application should look like, what container image should it use, and we'll just send it to the cluster. Now the controller will actually compare the current state of the cluster. Now, what is the current state of the cluster? The current state is it's not running any application. Just take it as an example. Right now, no application is running. So that is the current state. The desired state is the Redis application should be running, right? So it will compare these both. The controller or the control loop will compare these both states, and it will try to match the current state with the desired state. So it will show, okay, in the current state, no application is running. That's cool. But in the desired state, the user has requested that a Redis container should run. So it will compare these both, and whatever changes are requested by the user in the desired state, it will apply to the current state so that these two equalizes, right? So that is the main job of a controller. Now, that was controller. What exactly is a controller? I hope you got the idea of what is a controller. Okay. Now, the Kube controller manager component in your master node manages all the different kinds of controllers or these particular control loops in all the functions in your cluster, right? So there are different kind of controllers for each component, right? So we have a node controller that sees the node states. We have the deployment controller, pod controller, replica set controller. Now, if you're not familiar with all these particular concepts, that's completely fine. But just note that all the Kubernetes objects, be that pods, deployments, replica sets, volumes, persistent volumes, nodes, all these particular Kubernetes objects have their separate controllers. And all these controllers, the main function is to look out for the separate cluster states, right? For example, the node controller. So it will look out for the node states, whether the node is running properly. And if a new request comes in to run a containerized application, it will see, okay, which node has the capacity to hold that particular application, right? It will inform the API server about the current state of that particular node, right? Now, the important thing to note here is that it only monitors the state of that particular component. For example, the node controller will only monitor the current state of the node, and it will compare it with the desired state and try to match these up. It does not, I repeat, it does not perform any other operation, right? For example, if a pod is not running, it will just inform the API server that the pod is not running. It will not try to fix that particular pod. Okay, that is what I mean by only monitoring. The fixing of the pod will be done according to what the API server commands, right? The API server will see, okay, what is the issue with the application? And then when the issue is solved, talking to other components, which we'll see a little bit later, then it will again go to the scheduler, which will schedule the pod. So the scheduling of the pod or the scheduling part is done by the kube scheduler only. The main job for the kube controller is to just monitor the state of these particular different components. We have the node controllers, pod controllers, service account controllers, and all that fancy stuff. So I hope you got the point of what is the main job of the kube controller manager. Before moving on to this last component, which is an add-on component for the master node, I just wanted to make you understand how these three work simultaneously. Okay, the API server, the kube controller manager, and the etcd, how these three work simultaneously, and the kube scheduler, of course. So how these three work in sort of a workflow manner. Okay, I hope you are able to see this diagram clearly. Let us assume a situation, right, that a particular node is down. The worker node, which has your application in it, which we'll look into a little bit shortly, that node goes down, okay, and your particular application is just laying as it is, okay. Once the node goes down, the machine is down, the application would be just as it is, okay. It will not be running, the application will fail to run, okay. Note this thing. The node goes down, what happens then? The controller manager informs the API server. As I mentioned, its job is to continuously monitor. So as I mentioned, there are different controllers for each K8s object, right? So here, the node controller, as I mentioned when we were talking about the controller manager, is continuously monitoring the node, and it just notices that the node goes down, right? And your application is just laying as it is. So it will first inform the API server, right? Then the API server will inform the scheduler, right? The kube scheduler, okay, it will inform that, okay, the node is down and there is an application which does not have any machine to run into, right? The API server will inform the scheduler, and then the scheduler assigns a new node to that particular pod or your containerized application. So this is sort of done in a loop, okay? If the node goes down, the request will go to the controller manager, then it will inform the API server, and the API server informs the scheduler, and then the scheduler assigns a new node, right? As I mentioned previously, the main job for the kube scheduler is to find the best fit node to run a particular containerized application. So that is what it will do. And this whole is a loop, and this particular loop is called as the reconciliation loop. That's a very big name for people who are just hearing it for the very first time, but it's again an important concept to note, and this is sort of an overview of what a reconciliation loop looks like. Okay, you can search it more on Google. You can directly Google it, reconciliation loop in a Kubernetes cluster, and you'll understand a lot more about that particular concept. But I just wanted to make you understand how these components actually communicate with each other, right? How the request goes in sort of workflow. And one thing to note is that all these particular requests, everything which is happening, the data is getting stored in etcd at the backend. So that is not to be missed at all the data in the operation that we have, everything is stored in the etcd database. So when the node goes down, the pod is laying as it is, right? So that will be stored in etcd. Once the controller manager informs the API server will validate the particular request, and it will store the data in etcd, and all other components that is involved, they store data in etcd. So simultaneously the data is getting stored as well. So this is an important point to note. I hope you got the idea of how these components are actually working together, right? That was all about the master node. Okay, one component is left, that is the CCM. It's sort of an add-on component, right? It's called as the Cloud Controller Manager, CCM, Cloud Controller Manager, and it's generally used when we want to talk to an external cloud provider's API. So that could be Azure, AWS, GCP, and all other cloud providers that are out there. If we want our Kubernetes cluster to communicate with their API, with external cloud providers API, we use another component which is called a CCM. It's there, but we generally don't use it if we are just learning stuff, or we are using a local Kubernetes cluster. And this is how the master node or the control plane node looks like. Okay, so we have discussed all these particular components: the API server, scheduler, controller manager, etcd, and the CCM as well. API server talks to all of these particular components, and the other components can talk back to the API server if they face any issues or if they have something to update. Okay, I hope you got the idea. This was the master node. So master node is responsible for all the admin related tasks of your entire Kubernetes cluster, right? You can get the idea of that. So that was the master node that we just talked about, maintains all the admin related tasks of your Kubernetes cluster. Now the worker node is where the actual magic happens. The actual work happens inside the worker node. Okay. The name itself suggests it's a worker. So it does the work. That was a really silly analogy, but I hope you get the idea. So let us, one by one see what are the components involved in the worker node and how they all communicate with each other. Let us start with the kubelet first. So the number one component in the worker node is called as a kubelet. So it's pretty simple. Kubelet is basically the brain of the worker node. Okay. Now the API server, if you remember, is the brain of your entire cluster, right? The most important part in your entire cluster is the API server. And it's also, in a way, the brain for the control plane node itself. So when we are talking about a cluster-wide view, the brain is the API server. When we are talking about a master nodes view, the brain is the API server itself. And in the worker node, when we are talking about the brain, that is the kubelet, the brain of the worker node. Okay. Now, kubelet is the agent that runs on each node, each worker node. But now, whenever I'll mention a node from this part of the video, I'll mention the worker node. Okay, this is the worker node that I'm talking about. So it runs as the kubelet runs as an agent in every node. Okay, if you have multiple nodes, there would be one kubelet in each and every node, separate kubelet in each and every node. Okay. Now, the main job of the kubelet is to continuously poll the API server for more requests. Now our main application is running inside the worker node. So basically the kubelet will continuously poll or ping the API server for getting more requests. For example, if the worker node is sitting idle, it does not have anything, so it will keep continuously polling the API server, and that's how the API server would know, okay, this is the particular node that is sitting idle, and if I have any more requests, the scheduler will schedule that particular request on this particular node which is sitting idle. So again, kubelet continuously polls the API server for more requests, and also apart from this, it also keeps telling about the current state of the worker node to the controller manager, as I mentioned. Okay, the node controller, if you remember from that particular concept. It also talks to the container runtime. We'll look container runtime right now, but if you are familiar with Docker or the containerization concept in general, the container runtime is what actually is used to run your application, right? Run your containerized applications. So it continuously talks to the container runtime and sees whether the application is running properly or whether there are some issues as well. If there are some issues while the containerized application is running, it will go to the kubelet. Okay, and then the kubelet will inform the API server that there is an issue with me, fix it. And then we have all the components in the master node that will work together and fix that particular issue. Now kubelet also manages all the pod related operations, or equal to your containerized application, all the operations, create, update, delete, everything which is happening inside the worker node related to pods, related to any other components in the worker node that we just saw right here. All the operations are being managed by the kubelet. Essentially, again, it's doing all the brain tasks of the worker node, what our brain does for our body, right? That's why it's also, I like to mention it as the brain of the worker node. Okay, I hope you get the idea of main function of kubelet. I've been talking about pods a lot throughout the entire video, but a pod is basically the smallest Kubernetes object. Okay, as I mentioned, Kubernetes has an API, right? And all these separate components, the pod, the deployment, and all the other functions that we use are the objects of that API, right? If you are familiar with the API concept and how it works. So pod is the smallest Kubernetes component, you can say, or the smallest Kubernetes object in terms of the technical term that we mentioned. It's the smallest object, and this is where the actual container runs, your containerized applications. So if you see the diagram here, this is a pod. Okay, these are two pods are running inside your particular node, and here is your containerized application running inside a pod. Okay, now you'll ask me, hey Kunal, why did we need a pod actually, right? Why can't we run our containerized application directly? That is a very genuine question to ask. Now the main function of the pod is that number one, it encloses your containerized applications as we are just seeing here. Number two is that why are we doing this in the first place? Because the pod helps the containerized applications to share the same resources and the same network. For example, in one pod, generally the practice is that in one particular pod, you have just a single containerized application running. Sometimes in production use case, you might have two applications running. So what is the use case for that? For example, you have your main containerized application and you have another container which is running your database, and these two are communicating with each other. Now imagine a situation where you are running these two containers separately here, right? You would have to define the network rules. You would have to define how these two will communicate with each other. You will have to define, the volumes that they will share, and then you will have to connect these to volume and all that fancy and sort of challenging stuff that you would need to do. Now, in case of Kubernetes, if this whole is enclosed inside a pod, it is pretty easy because all the containerized applications in a pod share the same resources and share the same network. So you don't have to define those particular rules. These particular containers will be able to easily communicate with each other when they are within a pod. So that is sort of one of the main advantage of using Kubernetes and why it uses a pod instead of a simple container. Okay, I hope you got the idea. If I was not able to explain you very clearly why do we need a pod, you can search it on internet, but I believe this is the reason why we use pods instead of a simple container. Lastly, we define how to run the containers, and everything is taken care of by the pod. Okay, we just define this is the container, these are the ports it's running onto, and these are the other containers which it needs to communicate if there are. And then we just define it, and the pod is the one which does the actual task of running these particular applications. I hope you got the idea. The next component is line in the worker node is the Kube Proxy. If you have heard the term proxy, you would know what are we talking about. So proxy is all about networks, right? So it's the pod's networking solution. The Kube Proxy is the pod's networking solution. Okay, this is how all the components inside the node, be that pods, be that the kubelet, be that the container runtime, all the components in the node, in a particular node, are able to communicate with each other, right, through the Kube Proxy. Why? Because it maintains all the network rules, right? How should they communicate? What is the address? Everything is maintained by the Kube Proxy inside a worker node. This is what I'm talking about, inside a worker node. Okay, now apart from this, it also manages the in-cluster communication. The in-cluster communication means worker nodes communication within all other components inside your cluster. Okay, inside the cluster, be that the API server, be that another working node which is running besides that. All these particular communication of a worker node to all other components is done by the Kube Proxy. Plus, all the external cluster communication is also done through Kube Proxy. For example, if your worker node needs to talk to a third-party application or a third-party component outside your cluster, that will also happen through Kube Proxy because it maintains all the IP tables, right? The IP addresses and the component's name inside it. So it maintains a kind of a table for that. And the main thing to note here is that the actual communication which happens, okay, is done by the Kubernetes object called as the service. Okay, the actual communication between two components, be that external, be that internal, the cluster, that happens through the service Kubernetes object. And Kube Proxy basically helps it to do that because Kube Proxy contains all the IP tables, the addresses, the IP addresses of the components, and it helps the service to do its job. Essentially, that's what Kube Proxy does. Okay, I hope you got the gist of what Kube Proxy does. All right. The last but not the least component is the container runtime. You might be familiar with that if you are familiar with Docker or the containerization concept in general. But let us see what the container runtime does. Interestingly, the container runtime has three internal components working together. All right. The number one is the container runtime interface itself. So the container runtime interface is the main protocol that helps the kubelet to communicate with the container runtime, right? To get the report of what the containerized application is running, how it is running, how it is managing. All these particular communication between the kubelet and the container runtime happens through the CRI or the container runtime interface that we're using. Now, currently, the latest version of Kubernetes that we are all running is 1.27. And in the version of 1.24, when Kubernetes 1.24 was released, the support for Docker or Docker shim was removed. Okay, so before that, the official container runtime interface for Kubernetes was Docker, but after the update of 1.24, now it's officially containerd. Okay, so we are using containerd as a container runtime interface with Kubernetes. The next thing is the CNI, which is the container network interface. So that's how the containers running inside your pod actually communicate with each other, right? The networking solution of the containers itself. So that is the CNI, container network interface. And we have three things here: Flannel, Calico, or Cilium. We can use any of these, but I think by default, you'll see Calico being used in a Kubernetes cluster of the latest version 1.27. I'm not sure about that, but you can definitely check that out. Okay, the last is the CSI, which is the container storage interface. That's the storage component of the containers that are running. So in that, you can either use Longhorn, that's a CNCF tool, and you can also use OpenABS. So essentially, the only thing to understand here is that the main component is the CRI, which is responsible for constant communication between the kubelet and the container runtime. And container runtime is what runs your actual containerized applications inside your pod. I hope things got a little bit clear here. All right, so these were all the major components that consist of a worker node. The important thing again to note here is that the kubelet is the brain. It talks to all of the components inside the worker node, that is the Kube Proxy and the container runtime. And through communicating with the container runtime, it knows about the state of the pods and the containers running inside those pods. Right? We covered all other components running in the worker nodes right now only. So all in all, if we take sort of a wider look of the entire Kubernetes cluster, we first go through the master node, right? Master node or the control plane node. These are all the components of the control plane node that we just discussed individually. And then there is the worker nodes. We can have multiple worker nodes, and we discussed all the components that each worker node has. So all these components, each worker node consists of these, right? That is important thing to note. So how does the worker node communicate with the main master node? As I mentioned, Kubelet is the one which continuously communicates with the API server about all the things that are happening inside a worker node. And inside a worker node, Kubelet is the one that communicates with the Kube Proxy and the container runtime. And through the container runtime, it knows, okay, what applications are running and what is happening inside the pod. That's how the communication looks like. So this is sort of, I would say, a nice overview of the whole cluster architecture, the components involved, and how do they all communicate with each other, right? If this is your first time hearing about this, I hope you were able to understand. And if this was something that you already knew, right, all these components you already knew, I hope you learned at least one thing new. Okay, that was my main aim here. Let's talk about kubectl. Okay, so kubectl is the Kubernetes CLI tool, right? I talked about we make request to a Kubernetes cluster, right? That's through kubectl. So kubectl is the CLI tool through which we interact with the Kubernetes cluster, right? Multiple clusters or even just a single cluster, we use kubectl to interact with that, or kubectl, or some people also like to call as kube control, but I like to keep it simple and call as kubectl. Okay, so firstly, it allows you to run commands against the Kubernetes cluster, right? If you're already familiar with that, you would know this particular thing. But if you need to interact with your Kubernetes cluster to see the running pods, to see all of the components that are running, you need to have kubectl installed in your local system. Okay. It also helps us to deploy applications, inspect and manage all the cluster resources, right? So again, all the management stuff happening with your Kubernetes clusters. And it also helps us to view logs as well of what is happening in each component that is running. Okay, so these are the main tasks of kubectl, and you can install kubectl separately through the binaries from the official website, and then you can easily talk with your entire Kubernetes cluster. Okay, so if I just show you how things actually look like in a Kubernetes cluster, okay, just to run a few commands in front of you and show you what the components that we talked about looks like in an actual Kubernetes cluster. So right now I am using 1.27. This is, by the way, Killer Coda. This is a free platform which you can use to test out tools or work with Kubernetes and all that fancy stuff. You can try it out on your browser itself. It's free to use. I'll link it down below in the description as well. Let's see, kubectl is already installed. Okay, if I just type kubectl, so you can see all the commands that you can run with kubectl. Okay, but the most basic command that we can use to explore our cluster is get command. Okay, so if you see here, the get command is basically display one or many resources. Okay, so if I just see kubectl get nodes, so right now you can see two nodes are running. One is the control plane node that we just talked about, the master node, which has the control plane components running inside it. And one is the node 01, which is the worker node. Okay. By default, if you don't have a worker node, you would definitely have a control plane running by default. That is for sure. Okay. This is something to note. Now, if you want to see what are the control plane components that are running, right? So you can do kubectl get pods, right? Minus n is for namespaces. If you're not familiar with the concept of namespaces, you can refer to the documentation, but namespaces are essentially used to group Kubernetes resources together. Okay, so if we explore the kube system namespace, kube system namespace is where the actual control plane components are running, right, as pods. So these are all the pods by default which run in your particular system, okay, in your particular Kubernetes cluster. So if you want to see the control plane components, one is etcd, right? Etcd is the data store that we just talked about. The Kube API server is running, the controller manager is there, right? And the kube scheduler is also there. How to define that these are running in the control plane? You have the name control plane written in front of them, right? Now there is a reason why the name control plane or the name of the node in which these pods are running are written, which is a separate concept called as static pods, which we'll explore in a video of its own. But right now, just note that these are the components that are running as pods in your container, okay, in your cluster, I'm sorry. And additional things are running, which is Kube Proxy. So Kube Proxy is also running as a pod. And if you we'll right now inspect the node itself, the worker node, and you'll see that Kube Proxy, this is the Kube Proxy which is running in the node itself, the worker node, okay. And Calico is again running in your cluster, which is the CNI, the container network interface. Now, as I mentioned, these all components are running as pods, right? So you can also see the containers that are running, because pods are essentially what encloses a container, right? So the pods which are running are the actual containers which are running, right? And as I've mentioned previously, that the container runtime interface to interact with the containers which are running is container D, and to interact with container D, we have something called as CRI-CTL, or you can call it as CRI-CTL. So if we do CRI-CTL PS, so this will list down all the containers that are running right now. All right. So you can see kube scheduler container is running. That's how you can see the kube scheduler pod which is running in the control plane, right? And you can all see the containers that are running. You know, control plane is running. We have Kube API server. You also have etcd and Kube Proxy as well. So you can see the containers are running, but they are running as pods in your cluster, right? So that is something to note here. Now, if you want to actually see what is running inside your worker node, let us see that. So you can do kubectl describe nodes and then the name of the node. That we can also do with the control plane node as well. But right now we want to do it with the worker node. So these are all the activities that is happening inside your node as of now. So the events tab is what are the processes or what are the events happening inside your node. So Kube Proxy is there, you know, Kubelet is running right now. You also have the node controller from the controller manager, right? It is also running and it is monitoring the node. It is, you can see it is registered with the node 1 in the Kube controller, as I mentioned, the node controller, right? Which monitors your node state. So that is running. You know, you have Kubelet, as I mentioned, and the node controller is again running as well. And right now we don't have any containers running inside this particular node, right? Because we don't have any pod running. Just to show you how we can run a pod, it's as simple as running kubectl run, let's name it as nginx, and with the image we'll give nginx. Okay, so this command is used to run a basic pod with the container image as nginx, and the pod name would be nginx. So it will create a pod, it will create a container. When we do kubectl get pods now, so it's in the container creating state. We can just type the watch flag to, you know, watch it through the process of creating a container. When it gets ready, we can inspect it. Okay, so you can see the pod is running right now. Let me just do it like this, and if we do kubectl get pods -o wide means it would display additional information as well. Okay, so as you can see, the pod is running, and the node by default is the node 1, the worker node. So again, an important concept to note: the scheduler will not schedule the pod, the application, the containerized application, or any new application that we want to run on the control plane node by default. It will always schedule the pod in the worker node. Why it does so, why we cannot schedule any application on the control plane, that is a separate concept called as taints and tolerations. When we study that, we'll have the reason for this particular thing. Okay, I hope you got the idea. Now if we just do kubectl, you know, describe the node 1, if you just scroll down, you'll see that in the non-terminated pod section, you'll see a pod which is called as nginx. It was not there before, it is right now because the pod got assigned to the node 1. If we want to describe the pod itself, we can just say k get pods. Firstly, we'll see, okay, engine is running. We can type k describe pods. So PO, so k is alias of kubectl. We can use that. So if you just see, if you describe the pods, and if you just see the node here, it would mention node 1 because there is only one worker node running, right? We can manually schedule the pod as well if we have multiple nodes. For example, if you have node 01, 02, and 03, you can schedule your pod according to your needs to the other nodes as well. But by default, it will only get scheduled to the first worker node that is there. Okay, and right now we only have one worker node. I hope you got the idea. And you can also see that the container ID, container D is running right now. So we talked about the container runtime in a worker node as well, right? Which actually runs the containers itself. So you can get the information for that. What is the container interface running by running kubectl get nodes and the name of the node, which is node 01, and minus o void again displaying additional information. And here you can see the container runtime is container D, as I mentioned. The current version of Kubernetes, which is 1.27, runs container D as a container runtime. Okay, so it's visible there as well. All right, so these were the things that I wanted to cover in the very first video in this particular series. I hope you were able to understand the cluster architecture, why do we actually need Kubernetes, and sort of how things are structured in a live Kubernetes cluster that I showed you just now. Before we part ways, I just want to mention a few things. Number one, this is again not a Kubernetes from scratch course. I'm just sharing my learnings with you all as I am preparing for the CK certification. So this was just an introductory video to get you up to speed as to what is Kubernetes and understanding the cluster architecture. The videos from now on would be sort of the main important topics from the curriculum that I'm currently learning for the CK certification. If you aren't familiar with these concepts or you want to study Kubernetes from scratch, that means from the very ground up, to get up to speed to what exactly is Kubernetes and how you can start working with it, I would suggest you one very nice resource to head over to right now, which is Kubernetes 101 workshop by Sayam. So this is that particular workshop, Kubernetes 101 on Kube Simplified channel, and this is given by Sayam Pathak himself. So in here, he teaches Kubernetes from scratch, from ground up to what is Kubernetes. He also explains the Kubernetes architecture and all the important concepts that are involved in the Kubernetes ecosystem in general. So you can definitely go to this workshop if you want to learn about Kubernetes from scratch. And in my series, the videos that I am making, that would be just learning in public, sharing my learnings with you all. I will definitely try my best to explain the concepts in the most simplest way that will help me to sort of revise the concepts, and that would also help you in order to learn something new, at least something new from my videos as well. So yeah, these are the few things that I want to mention. This was just the basic video of cluster architecture, and from here on we'll definitely dive into very interesting topic that I'm currently learning right now, and you can be a part of that learning journey as well. So yeah, that was about it for the very first video in the series. I hope you were able to understand. All the important resources and links related to the concepts that are explained in the video are in the description box, so you can definitely check those out. And if you have any doubts, if anything was not clear, or if you feel that I can improve on something, you can definitely let me know in the comment section down below. I would love to improve on my speaking skills, also my explanation skills, because the main aim is that you at least get one thing out of one learning out of these particular videos, right? So that is the main aim here. Yeah, with that, I hope to see you in other videos that I'll be making in this particular series, taking you all along my preparation journey. And if you like the work that I'm doing, you can definitely like the video, share with the community if you feel that it's adding value to your journey and your learnings. And yeah, keep learning, keep growing, and I'll see you in the next video. Bye.